All right, guys, welcome to the extension. For the extension today, we're going to be taking a look at our special triangles problems, and we're going to be looking at a type of special triangles problem that's a little harder than what we worked on in class. So in class, you took these notes with our 45, 45, 90 triangle. This is a special type of right triangle, and it follows a pattern where the two sides are equal, and to find the hypotenuse, you take that number that's represented by the two sides, and you just multiply it by square root 2. So it's the same value here, you just have to add a square root 2. And then we also looked at the 30, 60, 90 special triangles, where the hypotenuse, the longest side, is twice as long as the short side, and the middle side, the one that's not the longest or the shortest, is just square root of 3 times the short leg, right? So it gives us some shortcuts so we don't have to do SOHCAHTOA over and over and over again with these special triangles. Okay, so we looked at a couple in class that were like this that kind of let us get to our correct answer. This is the shortest side, so m is just going to be twice as long. It's just 14. N is going to be square root 3 times the shortest side. It's just 7 root 3. Okay, this should be familiar from yesterday. What we're jumping into today, though, is going to be problems that look like this. Okay, this time it gives us the hypotenuse and asks us to find a and b. Okay, and this one's a little bit trickier just because we're going the other way. So we're not multiplying by square root of 2. To find b, we're actually going to take 7 and we're going to divide by the square root of 2. Okay, and this is our answer, but the problem with it is I don't ever want a square root on the bottom. We're going to have to rationalize our denominator, which means we're going to have to get rid of this square root on the bottom. This is bad. To get rid of the square root on the bottom, we're going to multiply times the square root of 2, because that's going to get rid of our square root. But if I do that on the bottom, I also have to do it on the top. Okay, square root 2 times the square root of 2 is going to end up giving us square root of 4. Okay, I can't reduce the top anymore, but square root of 4 is just 2. So what we end up with is a fraction that looks like this. And it looks a lot sloppier than what we started with, but this is actually the most reduced version of a and b. So one of these sides is 7 square root 2 over 2. And remember, with the 45, 45, 90, both legs are the same. So this actually is the answer for both of these.
Now we're going to use the same exact idea as Mr. Matthews just discussed, but in this case we have a different type of special right triangle. This is going to be the 30, 60, 90, which tells us just a slightly different relationship. Where, like Mr. Matthews said, if we know the short side, we double it to get the hypotenuse, or we take the short side times the square root of 3 to get the longer leg, okay? So let's see what we started with over here to get the other two sides. I see that I have the 9, which is across on the 60 degrees, and I can see that that is bigger than that bottom side end. So that is my longer leg. And if we go back to our shortcut, the longer leg is x times the square root of 3. So if I want to just get x, I'm going to have to take whatever this longer leg is and divide it by that square root of 3, so I'm just left with my nice short side x. So if I come back over here, I'm going to take the 9. Now I'm going to divide that by the square root of 3. And like Mr. Matthews mentioned, in math, it is you are not simplified, you are not done if you have any radicals left in your denominator. So we must rationalize your favorites, I know. So we're going to multiply the fraction by the same thing on the top and the bottom. And we're always going to take whatever the radical is on the bottom, and that becomes our multiplier. Square root of 3 over the square root of 3. Now we need to multiply. Now over here, 9 times the square root of 3, we're not going to do 9 times 3. That's just a regular old number, which we're going to multiply by a hidden coefficient here of a 1. So 9 times 1 is 9, and we just have that square root of 3 right on, divided by the square root of 3 times the square root of 3. Since they're both underneath the radical, we can multiply them for a new number in there. 3 times 3 gives us 9. And now we have to simplify from there. I can't reduce the square root of 3 any farther, but I know that the square root of 9 is just regular old 3. So 9 on the square root of 3 becomes divided by 3. And we can actually go one more step in our reduction. We can look at the coefficient out here in our denominator and ask yourself, can you divide that down or reduce it like a fraction? And I know 9 divided by 3 is just 3. So I'm left with 3 times the square root of 3 as my short little side here. So since we started with the longer leg, we divided by the square root of 3 and rationalized the denominator to get the short leg. Now if we know the short leg, our shortcut tells us that we just have to double it, and we then have the hypotenuse. So I'm going to take my shorter leg, 3 times the square root of 3, and I'm going to multiply it times 2. I'm going to do coefficient times the whole number to get 6 times the square root of 3. I can't reduce the square root of 3 any farther, so my hypotenuse over here is 6 times the square root of 3.